about tonight are ideas I've had over the last 4 years. They're not very well worked out, but every time I speak, it helps me work them out. What I'm going to tell you is that dreaming is our subjective awareness of the brain activation in sleep. And dreaming has been regarded as an unconscious mental activity, but it's not an unconscious mental activity. It is an altered state of consciousness. Dreaming is a state of consciousness that actually it precedes and benefits waking consciousness. So dreaming, instead of being a derivative of waking, is in fact the progenitor of waking. All of the sensory information comes from the outside world, waking, but from the inside world in dreaming. The brain is able to create a simulation, if you will, then, of waking is an important part of my new theory. That what dreaming is doing, actually, is providing the brain with a virtual reality program that it uses in evaluating external reality. We can do a lot of work on phenomenology. We can do a lot of work on subjective experience, especially if we try to get over the fact of interpreting the damn things. I've just come from Lisbon, where I gave something like nine talks, 4 of which were just young school kids. And those school kids they're open-minded. I mean, they're ready to understand a new approach like this and jump in with both feet. In waking, we process information from the outside world. In dreaming, all of the information comes from within the head. So there is a source difference of the information that's processed. Dreaming is very visual, extremely visual, which means that the visual system is capable of creating imagery that with the eyes closed in the dark. The brain is not only anticipating waking, but it's actually creating waking. A lot of 80% of dream content is in fact not a reproduction of experiences that have been had in waking. It is a prediction, a creative expectation of what might happen in waking. In waking, we remember quite well, but in dreaming, we remember very poorly. And that's the reason for considering dreaming to be an unconscious mental state, simply unremembered when we're awake. That's the only real difference in terms of consciousness between the two states, is that one is remembered. Waking is characterized by rich memory, dreaming by exceedingly poor memory. Sleep and dreams are not just a human phenomenon. All mammals have sleep and dreams, and they all have a sleep that alternates between deep or non-REM sleep and light or REM sleep. And most of the dreaming that is very intense and scenario-like and hallucinoid is associated with REM sleep. So we have a physiological comparison then between the human and the animal at the psychological level and the physiological level, and we map back and forth between psychology and physiology. And we don't ask ourselves what the dreams mean yet. We ask ourselves, what are the differences in the subjective experience, and what are the differences in terms of brain activity, and can we make some sense out of those, of a comparison of those states? We've got brain states in both subjective conditions, and we have an animal model in which we could even ask questions at the level of cells and molecules. When we study the physiology of sleep, either in humans and or in animals, we notice three things that are important. One, waking and dreaming are both associated with activation of the brain. So the brain is turned on in both cases. The brain is very active in both cases. And that's, of course, counterintuitive. You wouldn't think that in sleep, your brain was activated, but there are certain parts of your brain that are more activated in REM sleep than they are in waking. What differentiates the two states are 2 factors so far. One is that the input-output gates are open in waking. You receive sensory information, and you can operate on the world. Whereas in dreams, the sensory motor gates are closed. You cannot receive information. It's actively excluded, and you can't send motor signals back out into the world. Activation A, input-output gating I, and there's a third factor, and that is the chemical modulation, factor M. And the chemical modulation is probably the most important part of the story, and it's the one that my reputation, I guess, depends most heavily upon. The systems of the brainstem, piece of brain that's as big as my little fingernail. In order for you to be awake and understand this lecture, you've got to be active with respect to your aminergic neurons. Now, aminergic is a funny word. You've never heard it, but it's the serotonin neurons, the norepinephrine-containing neurons, and the histamine neurons. All neurons that we thought might be more active in dreaming turn out to be much more active in waking. And they are subtracted from the brain when you go to sleep, and they are completely shut off during dreaming. Dreaming is a state of aminergic demodulation compared to waking. Now, at the same time that the aminergic system is going down, the cholinergic system is going up. So the cholinergic system is held in restraint during waking. Otherwise, you'd be hallucinating right now as you listen to me, instead of 3 hours from now when you get in your bed and you stop the aminergic neurons from firing. The cholinergic system will go bonkers and wild, and you'll have these wild dreams. The brain has changed its mind because it's changed its chemical composition. REM sleep occurs in the younger animal. In fact, it occurs most frequently in utero. Your brain is already self-activating when you're floating around inside your mother's stomach. Dreaming, or REM sleep at least, precedes waking by several months or years. It's not just that there is a night preceding each day, it's that in terms of our development over the long course in time, dreaming is the first state that we experience, or something like dreaming, what I call protoconsciousness. I don't know about you, but I can't think when I dream. I don't think well at all. I have very strong sensations and perceptions, very strong emotions, a very strong sense of agency. The dream is always about me. I'm always at the center of the dream, and I think these are important formal features that must be instantiated very early in development, even in utero, that the fetus is already a sort of self, at least by 30 weeks of gestation. And that self agent moves in a space. My idea then is that at a very early stage in development, there is a proto-self that moves in a proto-space, okay? And it moves in the space and also feels in that space. The seeing and hearing and all the rest of the sensation is probably sort of prepared for in some way that we don't yet understand. You're born with the capability of having all these emotional experiences, as well as having a sense of agency, moving in a space, and having the capacity to feel and to have emotion. So that's primary consciousness, and that's something that I think occurs in all the mammals, and all the mammals have REM sleep. It leads you to wonder, well, what is the function of REM sleep? But one part of it that's very surprising and completely counterintuitive is that temperature regulation depends upon REM sleep. If you take REM sleep away from an animal, he no longer can regulate his body temperature. What is body temperature doing for you? It's establishing a very narrow window for the operation of the brain. The brain does not function except in a very narrow temperature range. If you have a fever, you can't read, you can't think, you can't use secondary consciousness at all. And if you're cold, all you can do is try to get warm. Now, there's one other animal that regulates body temperature, and it's the only other animal that has REM sleep, and it is birds. Birds and mammals are the only animals that regulate body temperature. They are the only animals that have REM sleep, and in my view, they are probably the only animals that have something like dreaming in their experience, something like protoconsciousness. The thermoregulation story is part of a very important new approach to function that I've been taking with Carl Friston in London. He's a young, brilliant psychiatrist who is interested in free energy. What Friston says is that complex systems, and brains are certainly very complex systems, have to be very careful about the management of free energy. And one of the ways they do this is to keep the temperature extremely constant. The other thing that a complex system has to do to minimize surprise, to keep from going into a dysfunctional state, is to predict the consequences of its own activity. And the brain is doing this. The brain is not just copying the world. The brain is projecting expectations into the world. So that's what I mean by virtual reality program. All aspects of waking consciousness are in fact a projective experience, not just a receptive experience. So you project your model out into the world and you compare it with the information that comes into the system. So the free energy notion then very strongly enriches the theoretical structure that I'm trying to sketch for you. And now, how can you test the theory? Well, it's a very difficult theory to test, but there is one very impressive phenomenon that enables us to begin to test the theory, and that is lucid dreaming. With Ursula Voss in Germany, we've been studying lucid dreaming using quantitative EEG measures. It measures the electrical power under, say, 30 electrodes on the brain. And when a subject is awake, there's a lot of activity in the frontal part of the brain, okay? So secondary consciousness, I would say, is a frontal lobe function. When the subject enters REM and starts to dream, the frontal lobes are not reactivated. So no wonder you can't think, no wonder you can't remember, no wonder you can't direct activity. You are completely controlled by the automatic activation of the brain, and it's coming from the back of the brain. So lucid dreaming, Steve, is for me a functional a split brain preparation in which the frontal lobe is out of the picture or comes back into the picture, just as it is in waking. And so what it turns out that the frontal lobe activation of lucid dreaming is exactly midway in intensity between non-lucid dreaming, REM sleep dreaming, primary consciousness but no secondary consciousness, and waking with a lot of frontal lobe activation. The brain is both awake and dreaming at the same time. We always thought that it was either one thing or the other, but now we know that you can be doing both. And that enables you to think about lots of things in psychiatry that are characterized by what is called dissociation, the linking of one set of characteristics to another set of characteristics that aren't supposed to be linked together. And the brain dissociates automatically in lucid dreaming. And I think that's very exciting part of the story. Dreaming is very good at certain things that waking is very poor at. Dreaming is very good at imagining images, just in the same way that the phenomenology, the subjective experience of sleep and dreaming is reciprocal, one thing going on, the other going off. The physiology is one thing going on, one thing going off. Also, the capacity to think, the capacity of secondary consciousness as against primary consciousness going on and off. So we've got a three-way correlation going for us. Now I think I've finished within time, haven't I, Mr. Chairman? So let's have some questions.
Thank you, Allan, for an interesting career, really. It's inspired me all along the way. It seems your view of lucid dreaming is sort of reversed, that you're calling it a dissociated state, when in fact it is a state of increased integration. A state
Except
where,
for with waking reality. I mean, with waking,
well, we of course are, while in REM sleep, always asleep, meaning we're not in sensory contact, as you were saying, with the external world. When we are in a lucid dream, we don't become more in contact with the external world. We become more reflectively conscious, as you said.
And we become hyper-associative.
What happens in lucid dreaming is not more of a dissociation, it is less of a dissociation.
I agree.
And so we can become perhaps more integrated in it, as you're saying, when we can somehow learn to be lucid. So, good idea.
And I think that dreaming is hyper-associative, that remote associations are favored by this state. And that's what is strange about dreams. Things get tied together that you wouldn't think belong together, but they probably do, at least in terms of remote associations. So this stage of existence then is not only a preparation for reality in terms of giving you a virtual reality program, it enables you to understand the connections between things that aren't normally connectable. And it's probably also associated with scientific and artistic creativity. I think the story of sleep and depression is pretty good, but the story of REM sleep and another psychosis is almost perfect, and that's organic psychosis. According to me, dreaming is an organic psychosis, because organic psychosis, which is associated with alcohol and drug abuse, is characterized by visual hallucinations, memory loss, confabulation. I think organic psychosis is, in fact, the expression, the readout of the REM sleep system into waking. Just 2 days ago, I had a remarkable insight. You know what the time of maximal occurrence of REM sleep in sleep is at 11 a.m.? If you were to sleep for any reason, the maximal chance of having REM sleep in sleep is at 11 a.m. Now, 11 a.m. is my maximal performance time. The propensity that I have for REM corresponds exactly with my waking competence, which suggests to me that although the REM system is suppressed, doesn't express itself freely, I don't start dreaming. I sit in my word processor and I write a whole chapter in about 2 hours. And it's amazing the flow of capability that is associated then with this period of the day. Lucid dreaming and dream recall are both mistakes. I'm just telling you it's very rare. The spontaneous occurrence of lucid dreaming we've just studied in Germany, 600 German school kids, it peaks at about age 13 or 14. I think what you go to sleep for is to reinstate the biological memory, the genetically determined selfhood, agency, movement of body in space, all the rest of it, all the stuff that's generic is a design error.
Yes.
Doesn't mean I don't like it. I love it. I'm a great lucid dreamer, by the way. If you're lucid and you know it's a dream, then you can start to exert plot control. Tell yourself that you're dreaming while you're dreaming. That's the way I got lucid, was to use bizarreness as a cue. Steve introduces eye movements so people know they're in REM because a red light flashes in their visual mask that tells them they're in REM sleep. So, however you do it with pre-sleep auto-suggestion, use bizarreness or the nightcap or the night, what do you call it thing? The dream light or whatever. Yes, you can do all those things.
If you look at the neurophysiological side of it, there are two not only, this question of high frequency activities in the frontal cortex, etc., but also the so-called lambda waves of the occipital cortex, which indicate, that indeed this is really essential, to the development of vision.
Absolutely.
And that's again another aspect.
So rapid eye movement sleep is called rapid eye movement sleep because they're rapid eye movements. And they're rapid eye movements in all of you right now. You couldn't see unless your eyes were moving. Are you aware that that's the case? No, because you see the visual world is stable. But your eyes are moving at 20 times a second. So your brain must be recomputing the image 20 times a second in order that the room would stay still in the face of moving eyes. And this is the part of the predictive aspect of the free energy theory that I mentioned to you. And so I think that that's still another reason for taking seriously the notion that dreaming is in fact a preparation for waking.
I think we can adjourn now to tomorrow, and we'll hear more about lucid dreaming in some of these coming days.